Hello, my name is Juan Carlos Lozano, and I'd like to personally thank you for watching and scoring my lesson today. I am a student teacher at a small rural community where we service less than 300 students for high school and less than 1,000 for the full district. I student teach in calculus, algebra 2, a business math course, and then I transitioned to 7th grade to middle school where I teach language arts and algebra. My lesson today will focus on algebra 2, where I have sophomores, juniors, and seniors, and 8 of them are special ed. So they need lots of visual aid to help them understand the concepts a little bit better. It is an algebra 2 extended, so any kind of manipulatives I can have or any kind of visual aids definitely helps the full group, which I try to use almost every day. They're big time hard workers, and I really appreciate that. So for the lesson, I have my Common Core State Standard here, where it's understanding that polynomials form a system where we can add and subtract. There's multiplying, but we're going to be focusing on adding and subtracting. So the I can statement would be I can add and subtract polynomials, and that's what will be in their notes for today. For the objectives, I would have understand like terms, arrange in standard form, rewriting the difference of two polynomials by adding the opposite of the second polynomial, and using visual strategies. So those are the key points that I want my students to get out of the lesson. And now that I mentioned visual strategies, I want to come up with 3 different methods or strategies that we'll use that I consider best practices. One of them will definitely be color coding, just by putting little dots of colors on top of like terms, so they're able to group the colors together. Another one will be shaping. Maybe you shape like terms as squares, or maybe you want circles or triangles, whatever they may use, they're able to shape. Another best practice that I use is the use of these colored transparent square tiles. And this works great for kinesthetic movement. It's a great manipulative for those who need to see what's being grouped together, what's like terms. They're able to move it around and shift, and they loved it. So I hope they really, really loved these, because I love these a lot. I'm hoping that works out pretty well. I use lots of direct instruction as we're focused on notes for the very first lesson. That I always have 2 lessons. The first lesson is we focus on the concept. I give them the notes. We do lots of examples, pictures, graphs, whatever it may be. And the second lesson is always applying what we learned to something that they can apply to real world. So like today, we'll be learning the concept, and then tomorrow would be a real world application with whether it be medical sales or sales and revenue. Even aviation requires adding and subtracting polynomials, and I think they really appreciate that when they're able to apply it to real world, because it's not just memorizing, but it's actually actual application, and I believe they learn it better that way. I thank you very much for your time. Alright, as you finish up your warm-up, please put them away. Put your warm-up away and get out a piece of paper for your notes. Then I won't. I don't know. I don't When you're done with your warm-up, please get out a piece of paper for your notes. And let's begin. Remember, a smiley indicates that you must copy the material onto your notes. So when you see a smiley, please copy. We will be adding and subtracting polynomials. This is a Common Core State Standard, which applies mainly to myself. And we're going to be understanding that polynomials form a system that analogs to the integers. Namely, they are closed under the operations of addition, subtraction, multiplication, when we add and subtract and multiply polynomials. Alright, here's our learning target 2.3, which is adding and subtracting your I can statement, which is adding and subtracting polynomials. These are the points we're going to be focusing on as we learn this lesson. The first one, rewrite the difference of 2 polynomials by adding the opposite of the second polynomial. That sounds like a lot. It does. But when we get to it, it's easy. I promise you. It's rewriting the difference of the 2 polynomials by adding the opposite of the second polynomial. Difference means what? Subtraction, right? We're rewriting the subtraction problem by adding the opposite of the second polynomial. Remember in our warm-up? So when I check your warm-ups, I'm going to be like, oh, okay, yep, this person knew how to do it, this person definitely knew how to do it, alright? In our warm-up, when we distributed the negative, you wrote the opposite of the second polynomial. That's all it is. The second one is understanding the definition of like terms. The third one is arranging in standard form, which I had a question about already, if the order in which we write it, if it matters. And then being able to use a visual strategy to group and combine like terms. Essential question, this is what I want you to ask yourself after the lesson. Please explain or describe a scenario where knowing how to add and subtract polynomials will benefit you in some kind of real-world application, which I know that you've been asking for a while too. Real-world applications. All right, here is our title heading, Adding and Subtracting Polynomials. Today is February 19th, Thursday, February 19th. In your I can statement, I can add and subtract polynomials. I can add and subtract polynomials. If we do have a snow day tomorrow, by the way, we will do more real-world applications on Monday. Which I'm pretty sure we will have a snow day.
Don't talk about it.
Don't talk. Shh. I can add and subtract polynomials. That's our I can statement. Excellent. Yes, question?
Yeah, for the real world like situations, is that what we're going to be like for something we've actually been doing in class or just for math in general?
Actually doing in class. And it's math in general, yes.
It's like rational expressions?
Yes.
Okay.
Yep. All right, adding and subtracting polynomials. When we're adding and subtracting polynomials, one of the very first steps to do is to combine like terms. So like terms are terms that have the same variable parts. Variable meaning the letters, we know that. So for example, we have x squared plus 4x squared. If we look at our variables, all right, x and x, same variable. However, they have the same exponent, meaning they have the same parts. We're able to combine them. So an x squared is like saying it's 1x squared plus 4x squared, and we get 5x squared. Okay? Because we're able to combine them. 1x squared plus 4x squared is 5x squared. Again, let's say we have 5y cubed minus 2y cubed. Same variable, same parts. Same variable, same exponent, so that means we're able to combine them. 5 minus 2 is 3. 3y cubed. We keep this, all right? We're not doing anything with the exponents. We're not doing anything with the variables. We're only working with the constants right in front of them. That's how we combine the like terms. All right, any questions that I can answer for you? All right, so try these on your own, please. We have 2x cubed plus 4x cubed, 5x squared minus 4x squared. We have a 3y to the fourth plus 2y to the fourth, and we have 4y cubed minus 2y cubed. Please try these on your own. I'll give you about 2 minutes to do so. Question? Yeah, what's up? Don't get confused. When you multiply exponents, you add them. But however, we're not multiplying in this case. We're just adding and subtracting. So that's why we don't touch the exponents at all. All right? We just keep them. We're just working with the constants in front of them.
The same.
All right, if you've worked on the first one, 2x cubed plus 4x cubed, you should have gotten 6x cubed. 5x squared minus 4x squared, you should have gotten x squared. 3y to the fourth plus 2y to the fourth, you should have gotten 5y to the fourth. And 4y cubed minus 2y cubed, you should have gotten 2y cubed. All right, once again, we saw that they're the same variable, same exponent parts. So we just add our constants and keep the same variable and part. Okay? All right. Now let's say we have something a little bit more different. You see here we have 3 terms instead of 2. And then not only do we have 3 terms, but we also have a different exponent. We have 4x squared plus 2x cubed plus 3x squared. There's several ways on solving this. You can color code it. You can say, okay, we have 4x squared plus 3x squared. We combine those like terms. Why are they like terms? Because same variable, same exponent part. This 2x cubed is different from the rest because it has a different exponent. Okay? So we combine our like terms, 4x squared plus 3x squared. We know how to do that. We did it on the last slide. That's 7x squared And 2x cubed is just on its own, so it'll be 7x squared plus 2x cubed. But, yes, Jake?
Wouldn't it be the other way around?
You're right. It would be the other way around. It would be 2x cubed plus 7x squared because this is in standard form, which is what one of our key points was about. All right? Good job, Jake. Jake, just because you knew what standard form, or how'd you know that this had to be switched around?
Because
He
you
guessed.
go like
Higher
the
standard
lower
form
one,
on all
like,
sections.
Yes, you take the highest exponent and you go from highest to lowest. All right, that's standard form, highest to lowest.
Now I'm caught.
Now you good?
Yeah, I'm good.
Good. Standard form is from highest exponent to lowest. Very nice. And that was one of our key points as well. All right, so we good there. Let's try these on your own. All right, we have 6y to the fourth plus 3y cubed plus 4y to the fourth. And we have 2x squared plus 3x to the fourth plus 2x squared.
Wait, there's not a smiley face on this, so do I have to copy this?
Which one are you trying? By the way, I taught my dog how to lay down.
You're videotaping, it's not me right now.
Yeah.
Teaching.
My other dog knows how to sit, like he sits up, but my little dog, I teach him how to lay down. It's cute because he's small. When he lays down, it looks like he's still standing up. And I give him his little treat and he gets like really happy, like his tail wags like really fast.
His tail?
Yeah. Thank you. All right, let's see what we did here. Combining these right here, 6y to the fourth. We have this like term right there, and we have this one, right? So that should be 10y to the fourth plus 3y cubed. In this case, we have 2x squared and another 2x squared. We're adding them, so we get 4x squared. So 3x to the fourth plus 4x squared. Any questions on these? I can move on?
Yeah. Yeah, no.
All right, let's step it up a notch.
Oh no, I quit.
I want. No, it's. I know it looks a little sloppy, but it's nothing different really. It's just applying what we know. It's applying what we know. Okay. So I want you to think to yourself. Okay. What are we going to be doing when we have more terms that we're adding to a polynomial that has less terms? Is there anything different?
Yes.
No.
No.
Go ahead, Tyler. Tell me what you think.
No, you just combine the like terms and whatever is left over is just left over on the problem.
Exactly. You just combine like terms, and whatever is left over is what's left over in the problem. So in this case, you can use your color coding. Let's say you had a colored pencil, and you're really artsy, or like markers, or just like the really nice crayons or something.
I got markers.
Or gel pens. I know those gel pens. You can combine like terms that way, or you can do something like this. Let's say you're colorblind. You can do this. You can like, okay, my x cubes, my like terms for x cubes, I'm gonna circle those. So do I see any more x cubes? Oh, there's another x cube right there. Circle that. And for my x squareds, the variables that have the exponent of 2, I'm gonna square those, right? I'm gonna square those. Do I have any more? There's another one right there. Just my x's, I'm gonna triangle those. Do I have any more? Nope. And for what's another shape?
Line.
Clouds. Okay, we'll cloud this, right? So there's another way to do it, just to help you group. All right, that's a good best practice to use. It's just to help you group like terms. So in this case, we have 2x cubed minus 5x squared plus 3x minus 9 plus x cubed plus 6x squared plus 11. I color-coded the like terms, all right? I color matched the like terms. So we have 2x cubed plus x cubed. That gives us, and I have negative 5x squared plus 6x squared, 3x, negative 9 plus 11. So I just grouped them. I matched them. Okay? And we know how to do this. We know how to do this. We have 2x cubed plus x cubed, and that gives us 3x cubed. Negative 5x squared plus 6x squared. That gives us x squared. 3x is just 3x. We don't do anything with it. Just like Tyler mentioned, that if there's anything left over, we just leave it like that. We have negative 11, negative 9 plus 11. That gives us 2. So putting this together in standard form, remember from greatest to least, greatest exponent to least, we have 3x cubed plus x squared plus 3x plus 2. I wonder did I circle my answer? No, I didn't.
Oh, that's
Always I know. Always circle your answer. Always circle your answer.
So that's wrong.
So yeah, technically it's wrong. You have to circle your answer. I don't think I've circled any of my answers in this. Yeah, make sure you circle your answers. All right, good so far? Yes?
Yes.
All right, try this one on your own, please. By the way, if you do land up on camera, I have a way that I can block out your face.
Excellent.
Not because you're ugly looking,
blurred out.
it's just because
Well, the camera might
To
break
keep
if
fight
it
it-
sees me. Is that
Yeah.
why you put me at
to
cameraman?
keep
So it doesn't see me?
conventionality.
Confidentiality.
Conventionality.
Confidentiality.
Conventionality. Conventionality.
Like almost like you're saying confident. Confidentiality.
Confidential. and then-
Confidential.
Confidentiality.
To keep your face confidential.
There you go.
Alright, let's see what we got here. Alright, I'm going to circle these, my cubes. Any of my squares, I'm going to square these off. So I have another one, get my own right here. Just my variables, I will triangle those. And anything left over, I'll just plot my constants. Alright, so I have 3y cubed. I have my negative 2y squared minus 4y squared, which is a negative 6y squared. I have a negative 7y plus 2y, which is negative 5y. And then I have a negative 5. So my answer should be, if I did this correctly, 3y cubed minus 6y squared minus 5y minus 5. Alright, so you should have gotten that answer. Pretty easy so far? Yes? Excellent. Awesome, awesome. Alright, now we're going to be subtracting. Alright, we've been working with adding polynomials, now it's subtracting polynomials. Just like in our warm-up, okay, we had a minus. I wanted to see if you knew what to do with the minus. I had a few questions on it, like what do we do with the minus? I know how to do something with it, what do we have to do? We're going to distribute this minus sign right here into each term following the polynomial. Remember that in our key points it was rewrite the difference of two polynomials by adding the opposite of the second polynomial? That's exactly what we're doing here. We're rewriting this by adding the opposite of this polynomial. That's what this minus sign is doing. This minus sign we're going to distribute to the 3x cubed, to the 2x squared, to the negative x, and to the positive 7. I hand drew those arrows, by the way.
No.
So then rewriting this is exactly our key point, rewriting
I don't know.
the difference of the polynomials by adding the opposite of the second polynomial. See, we're adding the opposite of the second polynomial. Alright? So we distribute the negative sign to each term, making it opposite of what it is. Yeah, opposite of what it is. And then from there, this is nothing different from what we've learned previously. We just got to combine our like terms, which in this case will be 8x cubed minus 3x cubed, or negative x squared minus 2x squared, negative 5x plus x, and 1 minus 7. Alright, after combining like terms, gotta find your answers. 8x cubed minus 3x cubed is 5x cubed. Negative x squared minus 2x squared is negative 3x squared. Negative 5x plus x is negative 4x. And 1 minus 7 is negative 6. So our answer should be 5x cubed minus 3x squared minus 4x minus 6. Alright, I think this is one of our last examples. So try this one on your own, please. Try this one on your own. Remember, we're rewriting the polynomials by adding the opposite of the second polynomial. Adding the opposite of the second polynomial. Can you see it okay?
No, I was like if I try these on your own.
Oh, it's because of my accent. Try this one. Crap. Try this one. Who would like to go solve it once they got it? Who would like to go open the board? Yeah. And while you're over there, Jacob, you can get a Jolly Rancher out of the bag.
What bag?
There's a bag.
There's
of
a bag
Jolly
right there. What's in the other bag? The Ziploc bag.
My
So the chosen one.
my cool stuff.
What's cool stuff? Have you got it or no?
Yeah,
What is it though?
some cool stuff.
Chosen cool stuff.
Some cool stuff.
That's
By the way, in August I'm going to IKEA. I'm obsessed with that store. I had never heard about it until I started teaching.
What?
The main time
IKEA?
the store name after that.
It's like a furniture store.
The stores you want to use.
Yeah, they have everything.
Anywhere it's extra.
Yeah, they have. Yeah, they do. They have a restaurant in their store. Can you believe
Pizza
that?
stuff
You
you
bring
use.
me from a birthday?
Is that what you're going
Take you to IKEA?
Yeah, from a birthday.
Do the after.
Yeah, yeah, buy something.
Change the page.
Can't go to
Like a new kitchen or something. Let's just do that.
He is just shooting him off right
Yeah.
now. Good lord.
All right, Jacob. Whenever you're good to go, you can go to solve it. Please pay attention as Jacob takes the stage.
You dropped the marker.
You got 3.
So, you're talking about that for the intern now.
No, he's doing good. He's showing his work, which I'm really stressing you guys to do. Show your work. Show your work. Show your work.
So I'm just got right now. This is this is the one. I'm getting water.
Show your work.
I don't need.
Yes, it's one of the
Huh?
main topics.
So you
Don't look outside, everybody. Everyone looks. All right, Jacob. Looks like you said 8v to the fourth. There's nothing else there, so it'll just be 8v to the fourth. We have a negative 3v to the third, right? Should be negative because we're distributing. So I think that should be negative. And then we have negative 2v squared plus 12, yep, so that should be 10v squared, and then we have v, just one, v minus, oh yeah, 7, should this be negative 7v? I think it should be negative 7v.
So this is
And then a negative 4, just a negative 4, excellent. Let's check to see if it's right.
I'm gonna use
8v to the fourth minus 3v cubed plus 10v squared minus 7v minus 4. There you go. Looks good. Any questions? Are we good? We a little tired today? Thank you, Jacob. All right. Now pay super duper close attention to this. This is some good stuff right here. I have these cool, color, clear, transparent tiles. Believe it or not, this is something that my girlfriend did not get me. I got this on my own. Okay? Thank you.
It's not for your 7th grade this time.
And it's not, yeah, it's not for my middle school class. All right, so we're gonna switch over really quick. I need a pen. All right, we're gonna switch over really quick. Let's look at this problem. Go ahead, someone, Shannon, give me a polynomial. 2x to the fourth.
Q, you need a Q in there. 3Q squared.
3x cubed. Oh, cube. Okay.
4Q to the 5th.
4. All right. Give me another polynomial. Kennedy.
5x squared.
5x squared.
Oh my, you mean the whole problem?
Yeah.
Plus 6x to the fourth.
No.
Plus 12.
Plus 12. That's it?
Sure.
Okay, good. All right, with these little tiles that I specifically got myself,
You're so proud of that.
I am proud of these. Very cool. Oh, I have no life. All right, here's what you can use these tiles for. Okay, let's say you're just having a little bit of trouble. What you do with these tiles, you can use these tiles to help you, you see, help you group the like terms. So if I want my fourths to be red, if I want my fourths to be red, you see how I can group it like that? So I know that in this case, I'm going to have 2x to the fourth plus 6x to the fourth, which gives me 8x to the first. First. All right, let's say I want my constants to be yellow. I have a 4 and a 12. So I'm going to take 4 plus 12, and that gives me 16. I have just 1x squared, or just 5x squared, so it'll be 5x squared. And let's say I have just a 3x cubed. You know, the cool part about these is you can put them on, you're able to see them. You see, they're transparent. Isn't that cool? Everyone say it's cool.
So cool.
Everyone say it's cool.
Cool.
So then our answer would be 8x to the fourth plus 3x cubed plus 5x squared plus 16. Because we keep it in standard form. Everyone say that's super cool.
That's super cool.
Want me to do one more example?
No.
Good. Slow it. Give me a polynomial. What's that?
1
1
plus 1. What?
plus 1
I don't know.
plus
Squared
x squared
plus x to the 100.
x to the 100. Oh my gosh. All right.
I'll do the next one.
Minus. Go ahead, Blake.
Alright. 2x to the 100 plus 3 minus x squared.
Ooh, this would be good. Well, first of all, we should see. All right, boys. All right. First of all, we should see this minus sign and be like, okay, what we have to do here is distribute the negative side to each term in the next polynomial. You see, to each term. So let's rewrite this. We're going to have 1 plus 1 plus x squared plus x to the 100th plus negative 2x to the 100th minus 3 plus x squared. You see? It's the opposite of each. We just rewrote it with the opposite of each polynomial. So now let's combine our like terms like we know how to do. All our constants should be yellow. I can just combine these two, which is going to be 2. Right? We have 1 plus 1. Any more constants here? Yep, we have a 3, a negative 3, minus 3. 1 plus 1 is 2. 2 minus 3 is a negative 1. All right? Our x squared, we have a blue x squared, so I'm just going to have an x squared there. And then I have another one over here. That's a minus x squared. Or no, plus x squared. X squared plus x squared is 2x squared. Let's look at my hundreds. I have an x to the 100.
Let me move it up.
And I have a negative 2x to the 100th, minus 2x to the 100th. So 1 minus 2 is negative x to the 100th. Is that all I got? Yep. So our answer will be negative x to the 100th power plus 2x squared minus 1. That's also written in standard form. Pretty good? All right, awesome. I have individual baggies for you. If you'd like to use the tiles, you don't have to.
Where are they at?
They are super duper cool. However, because they are one of my prized possessions, I ask that you take care of them. They're not edible. They're not chuckable, so do not chuck them across the room, please. If you drop them, 5-second rule. Pick it up right away.
5-second rule. They're not even food.
No, I'm not saying to. I know, you have to pick it up within 5 seconds and you can't eat it, alright?
And you can eat it then.
And you cannot.
The 5-second rule is only for eating.
Oh, it's not. It's just to pick it up, isn't it?
No, it's for eating.
No, it's, yeah.
It's for eating.
It's, the rules go good.
Watch.
And
I
food
can
on the
drop
floor
you last
before
week.
My
the
life has been changed. Alright, let's look at, that was my best practice.
1, 2, 3. Yeah, see?
6 seconds.
Yeah,
Thank you, Jacob. Thank you for contradicting my argument.
Ayo.
All right.
Six.
Let's reflect. Like terms. We can only combine like terms when they have the same variable and same variable part, otherwise known as the exponent. We learn how to rewrite the difference by adding the opposite of the second polynomial, which is just subtract. That's what we're doing. We just subtract and we distribute the negative. We arrange the standard form, which, Jacob, tell me once again, what is standard form?
Oh, I got this.
Exponent from
High
biggest
exponents to
to
low.
From biggest to smallest. Excellent. And we use some visual for extra help.
I'll get you.
How can we apply this to real life? Now, this is what we're going to be working with tomorrow, if there's no snow day. Which, before, I mean, we couldn't say anything like, what, 5 minutes ago it was like all white? Now it's like clear. Yeah. Alright, but tomorrow we're going to be working with more real world applications, which would be using statistics. The examples that I have would be like medical practice, like for so much money spent on this instrument, so much money doing this, so, you know. So to find total revenue, sales, refunds, finding sums of area. Believe it or not, I told you that my brother was a draft designer for Solids and Structures, which is a company in Muskegon, and he has to work with polynomials when he finds areas of certain rooms and stuff. Path traveled of objects thrown or tossed at a certain point, and aviation. I had someone was in aviation, right? Tyler? Yeah. You'll be using polynomials and aviation as well. All right, so here's your class assignment. I have this. Please pick it up. I had it in front of me, but it's right here. For the first 5 minutes, please do what you can individually, and after that, you may work in your groups or may work in partners. Okay. It is due Monday. Please bring it done. Bring any questions you may have tomorrow, and bring any questions you may have on Monday as well.
It is, but yeah, it's
Are
due
there any
Monday to get credit
questions?
for it.
It's still due, but it's extra credit.
All right. Let's just say you need some extra help. I have this that I can email to you. I can email the PowerPoint to you if you'd like. And this is I Love Khan Academy, so you may use I have this website or the YouTube channel that you can use to get some extra help. For let's say you're at home and you just forgot, you can use that. All right. If there's no further questions, please come up. Please pick up homework, classroom assignment, and you may get started. Hi again. This is my reflective part of my video and of my lesson, and I'd like to talk about my objectives. I think that my lesson went overall very effective. I met my objectives as I fit every example in my presentation, my lesson, to fit the objectives. For example, if it was understanding like terms, I had several examples where it would fit. It was designed to fit the objective. Not only that, but as the on your owns, as I like to call it, after we do some examples together, I have them do independently. And I was monitoring, walking around, making sure that they were doing okay, and a lot of them had it. A lot of them had every kind of objective spot on. For those of them that did kind of struggle a little bit, I had lead questions, what I like to call lead questions. And it would just be something like, let's say they didn't know what to do with the negative in front of the parentheses. I would say, well, what normally happens when we have something outside the parentheses? And they would say, well, we would distribute. And I say, okay, well, what number do we see there? And they would think about it and be like, oh, it's a -1. It's like, okay, well, what do you need to do? So it's just leading them onto what's the next step or what's the next idea that they need to do. So I think my objectives were met that way as well. Again, with the classroom assignment afterwards. The classroom assignment, I'm so happy with the results because the classroom assignment I use as a post-assessment. How well did my lesson go? How effective was it? And I came back with very few minor errors. Something like, you know, where they added like -3 + 4 and they said it was a -7. Very few minor errors like that. But for the most part, all my objectives were met through the pre-assessment and through the on your owns. It was awesome. I'm glad to see that my lesson was effective that way. Through my assessments, my pre-assessment, which my warm-up was, normally my warm-ups, we come in and I already have a warm-up on the board and they know they get to that right away. Sometimes we cover it together. Sometimes I have them hold on to it for the exit ticket and I use it as a pre-assessment, like, hey, this is what I'm going to need to cover for the next day or whatever it may be. In this case, I had them give it to me as an exit ticket. And they definitely struggled with it. They struggled with subtracting polynomials. They didn't know what to do with the exponents. So they definitely struggled with it. But it was okay because it was something that they haven't been exposed to as much. So they were going to get a good taste of it today. And I'm definitely going to let it I'm gonna let that one slide because the post-assessment was definitely a lot better than I thought it was going to be. The classroom assignment, which was the post-assessment, like I mentioned before, it came back with very few minor errors, and it made me realize that my lesson was effective. This will definitely help me drive instruction, as I will always have pre-assessments and post-assessments. The post-assessments will allow me to see how well my lesson was. Was it effective? Did it do what I needed it to do? Were my objectives met? That's definitely something that I'm gonna have every single time that I can, some kind of post-assessment. And the pre-assessments I'll do not when necessary, but the post-assessments definitely throughout my teaching career I'll definitely have. Onto my strengths and weaknesses. My strengths, I definitely think that one of my strengths was my classroom environment. If students don't have a positive classroom environment and a great student-teacher relationship, I don't think they'd be able to learn. So I think I have a good classroom environment where they feel warm, they feel trusted, they feel safe, and they feel safe to ask questions, to talk amongst their peers for ideas, ask their classmates for certain questions, and I believe they feel that they're able to learn in that classroom. And so my classroom environment is key, and I have a great student-teacher relationship with my students, and that's why we're able to incorporate that humor, because I can. My differentiation, the 3 ways that I was able to strategize, especially from Algebra 2 extended course, where my students need more visual aid, and in this case where I used the color coding, the shapes, and the square tiles, which was great for the kinesthetic movers, where they're able to move around and shuffle. Oh, I see this is combined lights with this, and they were able to do that. So the tiles were definitely a big hit. A lot of them had it. Even some that they didn't really need it, they had them because it was a big hit. So the differentiation definitely helped out there. 3 different ways. Some even took out their gel pens, even though I took it as a joke. They took out the gel pens and were marking them, and that's awesome. So the differentiation definitely helped. I think my approach to teaching, I know a lot of it is direct instruction, sometimes cooperative learning during kind of study groups and things like that. But where I teach, where we do a guided practice and where they do an independent practice with the on your owns. I think that definitely helps out because they see me do it for the very first time. We do it together, and then they do it on their own. I think that's great for students. Another thing is the teaching of the concept today and applying it tomorrow. So today, of course, I taught the concept of adding, subtracting polynomials, and tomorrow, not only they're just going to forget about it and move on to something else, but they're going to apply what they learned today. And that takes away from memorizing. We're not memorizing how to do this, we're learning how to do this. How are we going to learn? When we apply it to something that we know we're going to use. So tomorrow I have an activity with my medical bills and sales and revenues, and that's definitely what we're going to be working on tomorrow, where we're applying what we learned today tomorrow. And that's definitely going to make me realize that they're learning and not just memorizing. My weaknesses. One of my weaknesses is definitely over-planning. I have a 48-minute block, and I tend to plan for an hour and a half, whatever it may be. I overplan. That's definitely one of my weaknesses. I try to get as much as I can into a day. Maybe it's because I get too excited about it. Whatever it may be, I overplan, and I need to work on that. That definitely needs to change as I teach in the future, because I want my students to get the right amount of learning possible. I don't want to over spoon-feed them, but just the right amount. And that'll definitely I'll have to modify my instructions for my students' needs. Another one is making my notes more interactive. Instead of them just kind of, today was just more copying the equations and solving them. I would like my notes to be more interactive, whether that be creating manipulatives or creating graphic organizers, whatever that may be, making it more interactive so that they're able to open things up and color here, sticky notes there, whatever it may be, to make it more interactive. I think it'll be more fun and engaging that way as well. And then one that I am struggling with is motivation. Even though I can tell my students that polynomials are used in aviation and medicals and entrepreneurship, whatever it may be, some of them just still don't have that motivation to want to learn, to explore more. And in a way that kind of as a mathematician and as someone who loves working with children and loves working, seeing and fostering their growth, it hurts because they really, you want them to do well, you want them to explore the wonderful world of math. So motivation, getting my students to be motivated, finding lessons that, individual lessons to apply extremely to them is what I'm looking for. And that's definitely going to influence my teaching along the road. I know that this is being a big learning experience, and I truly appreciate everything this has done. And thank you very much for watching my video, and have a great day.